Astronomy Cast, episode 273 for Monday, September 24th, 2012. Solutions to the Fermi Paradox. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me, as always, is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville. Hola, Pamela.
Hello, how are
You're
you?
good. You're in Spain. You're in Madrid.
I am in Madrid. I'm here for the European Planetary Sciences Conference and realizing I don't speak any Spanish. Sesame Street did not prepare me.
Really?
Yeah.
Oh. Good. What is the conference about there?
It's basically a review of planetary science all across Europe. Uh, Results from all of the missions that are shared between NASA and the European Space Agency. So I'll be hearing about Vesta, about Mars, about new plans that the Russian Space Agency has for going back to Mars. And it's a small, nice little international conference in the biggest conference center I have ever been to in my life. You could fit most of the conference centers I've ever been to into this one conference center. It's huge.
Yeah, there's some really big conference centers in Europe. So hopefully you'll be reporting on this at some point down the road, or in Star Strider, or we can reference it in a future episode. So that'd be great. So take notes and convince
It's
people
all
to
gonna.
to launch more spacecraft if you can.
We're trying. We're
Okay, good.
trying.
All right. Good. Okay. Well, so let's get rolling then. So in episode 24, we presented the concept of the Fermi Paradox. In short, where are all the aliens? And today we're going to examine the theoretical solutions to this problem. Maybe they're out there and they just don't want to talk to us. Maybe it's too hard to communicate. Maybe there are no other civilizations. Maybe civilizations wipe themselves out before they reach a certain point. So many solutions, and none of them very satisfactory. So Pamela, so this really leads to actually last week during our recording of Astronomy Cast, we actually wrapped up our episode on abiogenesis, and that somehow, and then, as you know, we do this as a live Google Plus Hangout, and so we've had a bunch of people watching, and some people asked some questions, and it somehow led into a conversation about various parts of the Fermi Paradox and some of the possible solutions to the Fermi Paradox, and we were having a great time. Everyone was talking, and I realized, okay, this should be a show. So we sort of tabled the conversation and posted it on the schedule, and now we've brought it back for this week. So before we kind of get into the solutions, can we sort of get a refresher again on what the Fermi Paradox is?
Well, it's basically the idea that Enrico Fermi, a Italian physicist working at the University of Chicago, one day at lunch basically said, "Where are they?" And this, of course, confused everyone he was eating lunch with. But what it turned out that he meant was, where are all the aliens? It should only take, depending on how you run your calculations, a few tens of thousands of years to a few millions of years to largely populate our galaxy. And if that's the case, why haven't they populated where we are? Why haven't we seen the aliens? Why aren't they regularly visiting in a way that is scientifically provable and everyone can agree upon? Where are they? And so this became Fermi's paradox.
And it really is a devastating paradox when you think about it. I mean, think about situations like you know, a little bit of bacteria making it to a sandwich. You know, within
Yeah.
a few hours or within a few days, that bacteria has made it to the entire sandwich. And so it's the same situation that if, you know, the Milky Way, for example, is only whatever 100,000, 130,000 light years across. I say only, but you know, and if you're moving at 1/10 the speed of light, and you're moving from world to world, then, you know, conservatively, it would take you about 1,000,000 years to move across the entire galaxy. And if you've sent some kind of self-replicating probes or colonies, you know, and give them a little time to catch their breath, it's still only going to take a couple of million years for these people
Yeah.
to, at speeds that are fully within the laws of physics. So there's no reason to believe, and when you think about how the universe has been around for 14.5 billion years, all it took was one span of about 1,000,000 years.
13.5 billion
13.5 billion,
years.
sorry, 13.5 billion years.
13.7 plus or
yes.
minus.
Sorry. 13.7 billion years. So you think about the universe has been around for that long, only just one moment
Yeah.
on one civilization on whatever 200 billion stars in our Milky Way, one intelligent civilization had to arrive and then just take 1 million years and boom,
Hmm.
colonize the entire Milky Way. And I mean, we're on our way to doing this right now, and we will absolutely do this. I mean, this is a drive that, that humans have had to explore and colonize every portion of the Earth, and we'll absolutely take it out into the stars. So give us 1 million years and we will have populated every planet in the Milky Way.
But this is assuming that we don't kill ourselves off.
So right, so then so if, with all those assumptions,
Yeah.
really, why do we not see any aliens? So what are some of the really sort of what is sort of the first real powerful meta argument that we see?
Well, I think the easiest way to look at it is, well, what are the things that would prevent us from doing that? And so first thing that comes to mind is disease. There's always the fear that there's going to be such a horrifying disease that it crushes civilization and civilization isn't able to rebuild itself. If it's not a disease, what about war? And if it's not disease or war, asteroid impact, comet impact, otherwise some form of natural catastrophe. And one of the truly terrifying things about a civilization as advanced as the one that we have now is we've used up all of our planet's easily accessible natural resources. So were civilization to have to rebuild itself from scratch, there's no easily accessible oil, there's no easily accessible coal, there's very few easily accessible minerals and metals left short of mining up the superstructures of buildings in cities that have been bombed out. So the idea of civilization being able to recover and rebuild to the point of being a spacefaring civilization again, it's very hard to imagine if we do in the planet we have now. So
But
disease.
but sure, okay, sure. But I mean, but every one of 200 billion stars that potentially could have supported life, was it disease 200 billion times? I mean, who knows how many intelligent civilizations came about? You just need one, right? You just need
And
one to not die of disease and not to kill itself, and then
so, but
boom,
those
colonize the
aren't the
entire Milky
only
Way.
those aren't the only the things that we worry about,
Hmm.
as those are most likely to stop us. Short-term finance. We have a global economic crisis going on where, due to lack of funding, we canceled our Mars sample return mission. The plans that we had between the United States and Europe to jointly go land one robot on Mars, scoop up rocks, go land a second spacecraft next to it on Mars, bring back the rocks. That was an extremely high-risk mission that we had a rather scary flight plan. Uh, but it's a former scary mission that we're not going to attempt. There isn't going to be another 7 Minutes of Terror movie describing how we're going back to get the rocks. That mission is dead.
Yeah, but
Due
ever
strictly to
200 billion worlds, everyone always cancels their spaceflight plans.
You can imagine that it's just never a financial priority, and as civilizations advance, as they run out of resources, they simply never choose to make their priority be space exploration.
So, I mean, this is really, sort of like you're saying that this is the doomsday argument, right? That
Yeah.
that that all intelligent life will always destroy itself before it
It
becomes a spacefaring civilization.
or up until this point in history, any of the civilizations that have thus far reached that stage have found some reason not to leave their planet. And then there's also like the stupid things that you have to worry about, such as if civilizations grew up on a planet where they evolve underwater, would they ever develop spaceflight? If a
But
civilization,
but I got to go back to always 200, 200 billion worlds in the Milky Way. We're an
thus
example of
far,
sure, we're an example of a race that has shown up on land and not on sea. So yeah, maybe 50% of them are on land and 50% are on the sea.
now, so the other thing is you have to presuppose that our civilization, which doesn't have this capacity yet, is a baby civilization. And so there's always the potential that imagine we're the most advanced civilization currently existing in the galaxy.
Right. So we're first.
And
We are the most advanced civilization in the galaxy.
or we're one of only a handful and the other few handfuls all destroyed themselves. It's
So not only are we first, but this capability is also very rare.
yes.
Yeah.
So there's so many different things that have to go right. And then there's also the matter of having resources capable of allowing you to do this. What if you develop civilization on a planet that doesn't have enough natural resources that are accessible in order to build the types of spacecraft that you need? You're running short on nuclear supplies, you're running short on easily accessible metals. And so you can develop an advanced civilization, but not an advanced spacefaring civilization.
Right. Okay. So just to kind of break this down for people, really, either life is very rare or intelligent life is very rare. We're first, right? And so we're in sort of relatively intelligent and we're first, or life destroys itself. Although that kind of really depends on it. But I think there's something else as well, right? Which is that life destroys each other.
That's true too.
That we aren't first. That in fact there is a civilization that has already colonized the Milky Way, and has made sure that the life doesn't expand. So that's
And,
the.
and
Do you want
this is
to?
yeah. So this is basically the idea that there is a angry protector civilization out there, and as soon as your society reaches a certain level of technological advancement, they come in and say no more. And so you don't hear about them until they're basically enslaving you. And so we're right now the equivalent of bunny rabbits that are cute and fuzzy but will cause no harm and thus don't need to be imprisoned and things like that. So
And you can
they have no
imagine an
need to
analogy.
interact.
Yeah, I mean, you can imagine an analogy here on Earth, right? Where we don't really treat, say, viruses that seriously until one comes around like smallpox. And then we
Yeah.
go, okay, we need to wipe that one completely out of existence because that one is very dangerous. And so you can imagine the same situation that aliens treat us sort of like smallpox or, like a virus. Right now we're the common cold, but if we get spacefaring ability, then they'll treat that like smallpox. There's a great science fiction series, The Berserkers. Was it?
I don't know that one.
Yeah, it's the berserk. Oh man, someone in the comments is going to mention it in a second here. But it's this concept, right? That you can expand it. As I said, you can expand at 1/10 the speed of light. And so instead of like colonizing, you just send killer spacecraft out, and you have these spacecraft show up at at every possible world, and then the spacecraft just stops and waits and watches for any evidence of a spacefaring civilization. And when it finds it, I don't know, blows up the sun or
Well,
something,
it's
right?
kind of the plot of Prometheus, although I have to admit the full plot of Prometheus was always a little bit mysterious to me.
Don't try to think about the plot of Prometheus. You'll only go mad. Um, but yeah, it's that, or it's kind of like 2001, right, where there was
Yeah.
but that was different because that was more of an uplift. So that really kind of collects all these together. So let's kind of lump these into one pile, which is the sort of
So the
there's no
civilizations
other.
never get to the capacity. So
Right.
they're underwater. They don't have the natural resources.
Yeah.
They live under clouds, and the idea just never occurs to them. So
Right. Yeah.
so um, so civilizations can't get there.
Yeah. So then
Um,
there's another whole classification then, I think, which is that they are there, but we just can't find them or communicate with them or really connect with them.
And so this is the idea of um, we would never recognize the communications from a life form that communicated extraordinarily quickly or extraordinarily slowly. So the passage of time, in some ways, very much matters. And
And
it's not necessarily only the passage of time but that's the one we think of.
right, but space is big, you know,
Yeah,
right? Douglas Adams has a great line about how mind-bogglingly big space is. That the intelligent civilizations are all just too far away from each other, and communication with them is just impossible.
yeah. And but that still doesn't fix the Fermi paradox, which says that they can go out and spread out in a million-ish years or more. That implies that they've chosen to keep themselves far away, that they've held back their exploration tendencies. And in a way you can understand a civilization making the choice not to exert the resources necessary to have self-replicating robots that go out and colonize the entire galaxy, knowing they'll never get the signals back, knowing that there's what is the point of sending out self-replicating robots to take over the galaxy when you can't be there to experience it. We abandoned Voyager to go flying through space, but we didn't make it self-replicating, and I don't think anyone would have argued for that.
I would have. Seriously, I would have. That would have been awesome. Fire it up another planet, have it build another Voyager, communicate with us. I absolutely would have argued for that. And then it would have come back, and it would have tried to kill the Enterprise.
Exactly.
Right, and so then you can imagine then that humans, for some reason, and we haven't figured this out yet, at some point, someone will kind of go, "Oh, here's the math. It doesn't make sense to explore the galaxy. Let's not bother." And everyone's saying, "Yeah, okay, yeah, no, that makes total sense. I don't know
And
why we
and
even
that's
thought of
that's
that."
kind of where I'm at is it's expensive, you won't get the information back, and so until we figure out how to colonize everything, which requires a whole new level of resources, that's harder to do in a million years. Uh,
Right, and as you said, economically, it's entirely possible that it's just not feasible under the laws of physics to do it in any kind of reasonable way.
well, I'm not sure the laws of physics so much as we're pretty good at building spacecraft that are capable of powering themselves for a few decades using various radiothermal generators. Um, but in order to be able to self-replicate, you have to somehow get to another planet, dig up and mine more nuclear resources, and so you have to be prepared to check multiple worlds before you can find what you need. Finding uraniums or plutonium or whatever you want is difficult enough on the planet Earth, where we can explore the whole planet at will. So just the idea of how do you get the power sources necessary to replicate and spread out, that raises all sorts of complications.
Yeah, yeah. Now you could imagine a situation where, for example, humans. I mean, we think that we should be listening to radio signals or beamed laser transmissions or neutrino emissions, but maybe there's a
No
communications
one's
method.
listening for neutrino emissions.
But maybe. Right, nobody is. Oh, is that what you're saying? You're saying that nobody
Yeah.
is currently listening. Yeah, that's right. Yeah. So it might be that aliens communicate neutrinos, which actually would be a pretty great way to communicate, since they can pass through light years of solid lead, and we're just not listening. And maybe in 10 years we're going to realize that, oh, neutrinos are way better to communicate with than radio.
They're just kind of hard to detect. It's that whole passing through light years of lead thing.
Um, what else? I mean, sort of in the same thing. They're too alien. You can imagine a
That brings up
situation.
the cultural difficulties of their culture doesn't have the desire to explore, and that's something that we've seen in a variety of human races as well, or human cultures rather, where there's certain cultures that simply don't have the must go out and take over every ounce of land on the planet. We are quite happy where we are, thank you very much. So you can imagine an entire world of cultures that just don't have the wanderlust that the people who founded America, Canada, Australia, and those countries had to get there.
So I think this is a great one, right? Which is that they really have chosen, and this is, I think a lot of people buy this one, that they have chosen not to interact with us, that there's some kind of galactic federation,
Prime
the
Directive.
Prime Directive, right? Which says, don't talk to them until they can fly their spaceships. What do you think about that one?
I think that one's pretty interesting, except there's well, how do they know we're here? Um, you would have thought that maybe they're somehow monitoring us if that existed, and there's enough telescopes out there that, we're pretty good at catching random rocks falling into Jupiter right now. You'd think we would have, in all of our images, managed to intercept something flying through the field, and even if they're good at building stealth spacecraft, they would have occulted a star now and then. Um, I mean, who knows if we would have seen it as anything more than a wink in and out that we ignored, but
So I mean, that's them ignoring, and then there's this further concept of the Galactic Zoo, where we're
yes.
actually, they've created a very elaborate zoo for us, and they're hiding evidence of the universe from us. Sort of a grand conspiracy.
I think that one's just a little crazy, but
Oh, unlike all
yeah.
the others.
Well, so the whole idea that the civilizations didn't leave their planet, that one doesn't require suspension of belief. The idea that we basically are in a solar system sized version of the Truman Show, that one seems a little bit more difficult because you'd have to forge the cosmic microwave background.
Yes, but they're super space aliens, and any civilization, what is it? Any technology, sufficient technology, would appear as magic, right?
Yeah, but we don't see it as magic. We see it as the Big Bang.
Right. Okay. And then, of course, that the I think another one is that the aliens are here all around us.
Yeah, no.
We just don't know. They're disguised as us.
See, that's just like Battlestar Galactica in 1984. And
Or V.
yeah,
No, I'm
or
trying to think.
V. No, V
They
we knew
live.
about.
They live. I'm trying to think. There's lots of
That
great
one we don't
examples
know.
of aliens, and there's a lot of pretty wingnut
Alf.
theories on the internet. Alf. There you go. Alf as a
The ultimate
solution.
alien living
Al-
among us.
Alf is the solution to the Fermi paradox. They are in people's living rooms watching television and eating cats.
Yes.
So then, of all, I mean, we've sort of gone through a bunch, and we've only gone through even really just a fraction of the solutions, the possible solutions to the Fermi paradox. And so, which one do you really feel which one feels right to you?
I think that, and this is going to be me being the more depressive one of the two of us. I think the idea that civilizations consistently, before they reach the stage of interstellar travel, suffer from either disease or natural disaster that crushes their civilization to the point that they can't return. I I can see that as being fairly likely because there's just a certain point where you've used up easily accessed resources and you can't return from. Imagine a global outbreak of Ebola. Imagine a global outbreak of any number one of the horrible diseases that's out there.
So, or not necessarily something so negative. I mean, something positive as well. Where they do the math and realize that it's just not feasible, and instead stay back on their planet and create a utopia. Or you still think it's the negative side?
I think I'm much more tempted to go with, by and large, it's the negative side.
Right.
Simply because we see in our own civilization, there's always that one rich dude who's willing to expend the energy to figure it out. Today, it looks like Elon Musk is going to be the one to figure out how to get us to Mars. And so there's always that one person willing to expend the resources. But interstellar travel requires your civilization to be much more advanced than we are currently. And we've come so close to, whether it be war, whether it be Spanish influenza, uh, we could have lost our society many times. All it takes is one asteroid. Um, Now, I'm sure that in the grand scheme of things, there are going to be, in the tail end of the probability distribution, the societies that don't care, the societies that run out of money, um, the societies that are simply too young.
So for me, and I'm glad you asked, I like the rare earth hypothesis. So I think for me, it's that either we are sadly alone in the universe or in the Milky Way, or we're first, or there's no sort of, or we're very first, or we're close to first. Because I don't know, it just feels always to me like when you get these exponential, everything's exponential in this idea that that any one world would then colonize the entire Milky Way. And so, in each one of those arguments that you posed, you would have to say, well, but every time for 200 billion stars it didn't work out, and that's all. It just feels like all you need is one, and then you get the whole galaxy. And so
It's well,
because we didn't,
you have to be careful with the 200 billion number,
of
because
course, of course, there's,
that's,
we need to go to the Drake equation to really
yeah,
do the math. No, I understand. But that's all, sure. So 10,000
yeah,
stars, one in 10,000, all it took
yeah.
was one in 10,000 to make it through the disease, the technology, the whatever, and then boom, you're off to the races. So, and then I think we would see evidence. And the other thing I think is that we would see evidence not only of other stars that were under the effect of a sort of, a highly advanced civilization. We would see them dismantling their stars, creating Dyson spheres, organizing stars together into weird
You just
patterns and
love
shapes.
the idea of
I
taking
know,
apart
I
stars.
do, but I think we would even see evidence of galaxies being dismantled and reconstructed in various ways. And so,
And
we can see out into the universe, and we don't see any galaxies that have been turned into big smiley
and
faces.
and the energy requirements of something like that, I just can't imagine something like that being considered as worthwhile to do. And this is, it's, yeah, 14 billion-ish, 13.7 plus or minus billion years seems like a long time, but our sun is only 4.5 billion years old, and it's one of the mainstream metal-rich um, types of planets that support life, or support planets rather. And we've found lots and lots of different types of planets that support stars, but what I haven't seen yet is just how far back can you go and still be finding stars that had planets.
Well, and we see, again, we see 200 billion galaxies around us.
Right, but
So,
most of those were looking back in time, so
for
as we
sure,
look back
yeah,
in time, we're not going to see the civilizations.
yeah. So that's all. I just feel like there's such huge numbers, and that it's not about the you seeing the fraction. It's that in any one of those galaxies or in any one of those systems, you would have this exponential expansion that would come from any intelligent civilization that was attempting to actually colonize its home galaxy. So that's all. And I just feel like if you looked out, you would see that evidence somewhere. So for me, the most compelling one is the fact that sadly or unfortunately, we're either alone, super rare, or first. So, but your option as well is pretty terrifying. So I mean,
Yeah,
both haunt me. And that's why I love
yeah,
the idea so much. This is like a horror story for space nerds, I
yeah,
think.
and yeah, no, the Fermi paradox definitely does say there's something wrong here, and
Yeah, I personally find the Fermi paradox really chilling, actually. So
so yeah,
very cool and so exciting. So cool. Well, that was great, Pamela. Thank you very much, and I'm really glad
thank
that
you.
this turned into a conversation from what happened last week. So hopefully that'll happen again. So enjoy your time in Madrid, and soak up the sun, and maybe pick up a little of the language.
I have to. I don't have yeah. When you start with zero, it's easy to learn.
Awesome. All right. Well, have a great time. We'll talk to you later.
Thanks. Bye bye. Cool.
That was fun. I love that topic. I really do. Um,
I'm gonna grab my polar fleece and then we can take questions. Hold on.
what? You're cold? Wow. Okay.
I'm freezing. Yes.
I got to save an export. Sorry, everyone. I'm just going to save an export, and then we'll get on to your questions and such. And export, save. Come on, we're safe. We're safe. Awesome. All right. And I was totally expecting that to be a complete and total gong show, but your Spanish internet worked just fine. So that's great.
As I said, it's the hotel part that makes it terrifying.
Okay. All right. Well, I got a ton of questions here, so let's get cracking here. So Christopher Long is actually commenting on another conversation that's happening on the Google Plus page, just about contamination of life. So what precautions are being made by scientists to prevent life from contaminating other planets like Mars?
Not enough.
That's it?
Well, so the problem is that it's very, very hard to get something as big as a spacecraft completely sterile. And we'd already sent a lot of things over. We, of course, lose rocks when there's big enough asteroid impacts. This hasn't happened in human history, but presumably it's happened in the past where we've flung rocks covered in life forms to Mars. So with Mars, I think it's safe to assume we've contaminated it. But with things like Titan and Europa, we're actually being very, very cautious with, as the missions in those systems, so first Galileo and now Cassini, get older, they keep far away, they both are going to be suicided, I think is the best way to put it, into the planet that they're at. So Galileo was plunged into Jupiter, Cassini will be plunged into Saturn. And so this is how we prevent those two spacecraft from contaminating potentially habitable worlds orbiting those two planets.
Let's see. So from Doulos 1981, this is on YouTube. Oh, just by the way, everyone, if you're watching this, you can post any comments and questions. You can post them on the Google Plus page, where in the stream you can post your questions on YouTube if you're watching it there, or if you can use the hashtag AstronomyCast on Twitter, and we'll get all those questions. So did the Mars jars prove that Earth life can survive on Mars? Do you know what the Mars jars were? Is that an experiment? I don't know about that.
I don't know that one.
Hmm.
So we know that there are places on Mars that, assuming they have the correct chemistry, life would be capable of existing. And so the temperatures are fine. A warm day on Mars is warmer than a cold day in Boston. The extremely low atmospheric pressures, some extremophiles can cope with that if they're underground.
Water bears.
I can't speak to that one in particular, but it's thought that once you get tens of centimeters or more beneath the surface, that there should be a habitable layer.
Fred Saberhagen. So as predicted, somebody did post in the comments that the Berserker series was written by Fred Saberhagen, and this is this concept of sort of a general concept of the von Neumann probe, which is this self-replicating probe that expands around the around the galaxy, spreading, either uplifting sentiment or horrible sun-destroying devastation. So,
And just to make one random share while we're in the middle of everything, I just checked the Indiegogo page for a Wingu, and we have met our Indiegogo goal with a few hours to
that's
spare.
awesome. That is,
So I just wanted
congratulations.
to root about
Kudos.
that.
That's
So
fantastic. Wow. So
yeah,
that's it.
and
So now we are no longer reliant on government. It is time to
well,
take
that's
control of space exploration.
that's the goal. That's
That's
the
the
goal.
goal.
I mean, it's going to have to clearly be a partnership, but this is the first step towards changing everything.
So Marius von Deventer asks, how do we know that humankind is not the most advanced thing out there? In other words, that there are other advanced civilizations might still be in their age of sail or Middle Ages. So I think that's the we're first argument, right?
Yeah, that is the we're first argument.
Uh, so absolutely, there could absolutely be other ones that are behind us. Spiker Dallas on YouTube says, "Wait till Voyager hits the studio wall at the edge of our solar system, like in the Truman Show.
Yes, yes.
I'm sure they would. I'm sure the aliens would shoot it down in their galactic zoo before we got there." Um, uh, so Nick Dupree says, personally, I think the solution to the Fermi paradox is pre-industrial societies and also non-verbal societies are abundant compared to the number of very few civilizations that are so far apart. So you may find pre-industrial tribes in neighboring systems, but very few spacefaring civilizations with no profit in contact. So, I mean, that's kind of a mixture, right? That's sort of like, that's the rare earth idea that we're first, or that, sufficiently advanced civilizations are very rare,
Yeah,
but also matched with the sort of dispassionate to uncaring argument saying that these aliens, they just don't care, whatever. We've got
yeah,
some asteroids. We don't need to explore the rest of the universe. So, or what you said, right? That they're not going to do the math, right?
yeah.
Um, so this is a good question, though, right? So R.D. Brewer says, what do you guys think is most likely? Are they out there and we either can't hear them or that we just won't be able to understand them?
It's that's the too slow, too fast argument. I don't
Yeah.
know. Yeah,
Mike Davignon says, I think a lot has to do with us hitting the life lottery with our solar system, that we have a big moon, Jupiter to protect us, and we only seem to have something bad happen every 65 million years or so. So that's a good question. I mean,
that's
do
the
we live,
rare.
that's the, or yeah, or that we happen to live in do you think we live in a solar system that's particularly safe?
It's it's hard to know. I think having a moon the size we do has definitely done a lot to help biology on our planet. Um, what's unclear at this point is how common are planets roughly the size of Earth that are in the habitable zone. We have no clue. And the combination of planet plus moon has got to be even more rare. And we just don't have any statistics on this right now. Where Kepler is only starting to be able to pick up Earth-sized planets. And that means there's just no data to have an opinion from.
Right. Um, so we've got a question that has nothing to do with Fermi Paradox. This comes from Haverton. What information do you have about the Russian Venera D Venus probe? Are there any other plans to return to Venus? And I
Oh,
guess,
uh,
the surface of Venus.
yeah, so vague memory from 2 years ago at the European Planetary Sciences Conference in Rome. The Russians had this really neat, and if you go back through my Star Strider blog, I blogged about it, had this really neat plan to deploy essentially lawn darts all over, I think it was Venus, where the idea was they were set up in such a way that the darty part dug itself into the soil, and then they had this little tiny antenna that sent up information to orbiters, and they also had plans, and I'm hoping I'm not combining two different planets here, They also had plans to deploy balloons that would spend significant amounts of time in the atmosphere. They've done balloons with Venus before. America's done balloons as well. But the plan was to do this again and do greater exploration this way.
Yeah, I mean, I've been reporting on this for 12 years now, 13 years, and we have written story after story about what the Russians are planning, and I can't think of anything that actually happened.
They tried.
Phobos
They tried
Sprint.
with. They did try. Yes, it just didn't make it very far.
Yeah. But I mean, there have been a lot of sort of
Plan.
wild plans, that we're going to send
Yeah.
humans back to the moon, we're going to send people to Mars, we're going to send missions to Mars. So there's been a lot of missions that have been proposed coming out of various people from Russia. And to be honest, I mean, some of the finest aeronautical engineers in the world come from
Are
Russia.
there?
I mean,
Yes.
yeah, I mean, the tremendous accomplishments during the Soviet Union. So
But their economy is struggling to find the resources necessary
yeah,
to
and
dedicate to
so it's
space.
just not a priority. And so you can have some amazing genius who says, "Well, here's how we could do this," and
Hmm.
then just can't get the funding to
Yeah.
do it. So it's too bad. I would be I mean, going back, I mean, some of my favorite pictures are the Venera images. These images seen from the surface of Venus. You're seeing these rocks right from ground level. And there was a great mission that I reported on a few years ago, where someone proposed doing a Stirling engine,
Yeah.
which is a certain kind of what's a steam engine, anyways, an engine,
Yeah.
but you run it kind of in reverse, and so you sort of have the cool center of your rover, and then you're using the energy of Venus making its way into the rover to power it until it just gets too hot and your rover's destroyed. But I think the proposal was that it would last for weeks, maybe months,
Yeah.
roving around on the surface of Venus.
And
Let's build that.
one piece of context we have to keep track of is when we look around the globe at who all has space agencies. You have Europe, which is collectively much more populated than America, and Russia. You have India, huge high density population. You have China, huge high density population. And so with America and Russia, we have two very large geographic countries that are pretty empty. And that means we don't have the same industrial base and tax base to draw random extra resources from. And now that we don't have the military complexes competing with one another, it's hard to find the justifications in two relatively small tax bases
Yeah.
to dedicate everything to outer space.
Josh Andrews is recommending Revelation Space by Alistair Reynolds as a science fiction book about an advanced race that leaves technological bear traps and destroy any species that triggers them. So back to that berserker hypothesis. So Nico Vastamaki asks, should we take the same procedure to not contaminate Venus as we do with Mars? I mean, talk about a hostile environment. What do you think? Do you think
I
any
think
precautions are
anything.
necessary at all?
I think that anything that would survive on Venus, we wouldn't expect to normally find in the clean room at NASA. So I think that the escapees that we'd have to worry about are probably going to get pretty well killed by the 900-degree Fahrenheit hydrofluoric acid, sulfuric acid, and
Yeah,
yeah.
30 times the pressure of our atmosphere.
Yeah, the extremophiles that like those conditions don't run wild in clean rooms.
I don't want to know them. I do not want them coming back here. So
No. It's the type of stuff you'd have to worry about on Venus is the type of stuff that can survive the hot springs and lava in like Yellowstone and other natural
yeah,
lava mantle. Yeah.
yeah. David Crowdery says, with all the plans for Mars, how long and to what point can we say that we can't contaminate? And I think that's a great point, right? Which is how long are we going to leave the kid gloves on, and when are we going to say, let's contaminate, let's terraform and lay down, giant mining operations, and like once the scientists are done.
I Scientists are never done. Talk to an
They're never.
archaeologist.
But I think that's probably a good reference,
It's
right?
Yeah, so I honestly think that Mars, we're going to take the kid gloves off on. I think where we're going to be overly protective is with Europa and perhaps with Titan.
Right.
If
But it's
if
that
Mars has
situation.
life, it's under the surface.
But it's this situation where you show up at a new job site to dig up and build a new strip mall, and but if you find a few bones, then give the archaeologist a little time to dig up the
Yeah.
bones first, and then in goes the strip mall.
Yes.
Yeah. Okay, cool. Well, I think you're gonna probably have to. I don't know what time it is there. Go to
It's 10
bed.
o'clock at night.
So
Yeah.
we should probably wrap this up. So what's coming up next? Oh, I know what's coming up next. I'm going to be interviewed with Ray Sanders at 10 o'clock Pacific tomorrow night. So
And
that's
then Wednesday at 4 Pacific, Emily Lakdawala will do the weekly science hour. Thursday at 10 a.m. Pacific is the weekly space hangout. And then I'm not sure what time the virtual star parties are now.
well, we're moving a little earlier now, so we're up to 7:30 Pacific time, 10:30 Eastern, which is great. Maybe we
Excellent.
can even get to 7. So I mean, we just hit past the equinox, so
Yeah.
the nights are getting longer and the days are getting shorter, and that's perfect for astronomy.
And it's going to be great because we should be able to start getting both European and American telescopes in at the same time again.
Yeah, that'll be great. Last night was great though. I think we had 7 or 8 telescopes live, so
Awesome.
it was quite a night. And yeah, and so you can find out all this information. I don't know, all kinds of places. Go to
Yeah.
cosmoquest.org, and you can find really great links to all of the stuff that we're doing on the on Google Plus and throughout the internet. You can map Vesta if you wish from the asteroid mappers, which is great. So that's the new project we're working on.
Yeah. So
Cool.
you can be among the first to see some of these images because they're not publicly available yet.
Special advanced access to the craters of
Yes.
Vesta. And
Yes.
and for science, you can will they actually put their names into the research papers?
Yeah.
Cool. There you go. So you can have your name in a research paper. So, well, wonderful. Well, thanks again, Pamela, and thank you everybody who was watching. We will see you all next time.
Sounds great. Talk to you later, Fraser.
Bye.
Bye bye.